Assalamualaikum warahmatullahi wabarakatuh. Today, our group will present to you about the way we carry out the two-story bungalow house construction project. Before we start our presentation, let us to introduce ourselves. My name is Abdullah bin Muza. My matric number is 08DK23F1196.
Assalamualaikum, my name is Muhammad Alif Hakimi bin Muhammad Amin. My matrix number is 08DKA23F1168.
Assalamualaikum, my name is Abdul Muhaimin bin Bohari. My student ID is 08DKA23F1213.
My name is Muhammad Hakim Daniel bin Muhammad Jeffrey, nombor matrix 08DKA23F1202.
In this presentation, we will explain to you about an introduction to the project, the cycle life management process for the project, detailed planning of the project, the work schedule for IBS project, cost analysis of the IBS project, organizing supervision and ensuring quality check for IBS construction, efficient management and resources allocation during supervision and quality control, strategy to enhance site supervision, a conclusion to summarize our key finding, and finally is reference and resources used in this project. With this topic, we aim to provide a comprehensive understanding of our approach and execution of the IBS project. First of all, let's dive into the introduction. The Industrialized Building System, or IBS, is an innovative construction method where building components are manufactured off-site in factories and then transported for assembly. This method replaces traditional labor-intensive process, offering a faster and more efficient alternative. For this project, our focus is on constructing a two-story IBS bungalow. By leveraging modular construction and prefabrication, IBS enhance quality control, reduce carbon issue in conventional construction, and ensure sustainability. With proper planning, supervision, and through quality check, we aim to deliver a structure that is not only quicker to build but also more reliable and cost-effective. This approach demonstrates how IBS is transforming the construction industry by solving traditional challenges and paving the way for better outcome. Next, I will explain the project life cycle management for our IBS project. This life cycle is crucial to ensure the construction of two-story bungalow is carried out with the efficiency, quality, and adherence to the budget and timeline. Let's go through each phase in detail. First phase is initiation. We begin with the initiation phase. The goal here is to define the project scope, determine feasibility, and establish the preliminary requirement. In this phase, we first conduct a feasibility study to determine if IBS construction is suitable for the bungalow design, location, and budget. Next, we identify all key stakeholders such as the clients, supplier, contractor, and regulatory bodies. After that, we gather the high-level requirement, which include the client design preferences, the budget constraint, and the overall project goal. Then, we create a project charter that outlines the objective, estimated timeline, budget, and the initial resources required. Finally, we obtain necessary approvals and secure the funding required to move forward. The outcome of this phase is a well-documented project charter and approval to proceed the next stage. The next phase is planning, where we create a detailed roadmap for the entire project. In this phase, we start by developing a work breakdown structure, or WBS, which break the project into smaller, manageable tasks such as site preparation, component fabrication, transportation, and assembly. We then Then create a schedule with clear timeline and deadline for every task, from procurement to final assembly. Resource allocation is another key step, where we plan for labor, material, and equipment, while clearly defining roles and responsibility for all team members. We also finalize the budget by estimating the cost for materials, labor, transportation, and project management. Additionally, we prepare a risk management plan to identify potential issues like material delays or weather disruption and develop strategy to mitigate them. Finally, we secure all necessary permits and ensure compliance with local construction regulation. By the end of this phase, we have a comprehensive project plan with a detailed schedule, budget, and strategy for managing risks. The third phase is execution, where the actual construction work begins. Here, we implement the project plan by carrying out all necessary construction activities. The first step is to prepare the construction site by clearing it, setting up utilities, and ensuring safety protocols are in place. Simultaneously, the IBS components such as precast panels are manufactured in a factory according to the design specification. These components are then transported to the construction site, where they are assembled and installed with precision to maintain structural integrity. During this phase, we also install essential infrastructure systems such as electrical wiring, plumbing, and HVAC system within the IBS framework. Throughout, we perform regular quality checks to ensure that all work meets the required standard. At the end of this phase, the physical structure of the bungalow is complete and all major construction tasks are executed as planned. The fourth phase is monitoring and control, occur alongside execution. The purpose here is to track the project progress and make sure everything stays on schedule and within budget. To achieve this, we continuously monitor task completion against the schedule and address any delays that might occur. We also track expenditures to prevent cost overruns and ensure the project remains financially on track. Regular quality checks are conducted to verify compliance with IPS construction standard. We keep an eye on potential risks and address any new issue that arise during execution. Additionally, we provide regular update to stakeholders, ensuring they are informed about the project progress, budget status, and any significant changes. This phase helps us ensure that the project stay aligned with its objective and allow us to make adjustments as necessary. Last phase is closure. Finally, we reach the closure phase, where we complete all project activities and officially hand over the bungalow to the client. In this phase, we conduct a final inspection to ensure that all aspects of the construction meet quality standard. We also compile all necessary documentation such as boot drawings, project report, and maintenance manuals and hand them over to the client. Financially, we settle any outstanding payments, finalize the project budget, and close all accounts. We then review the project performance to evaluate its success and document any lesson learned to improve future projects. Lastly, we officially hand over the completed bungalow to the client, ensuring they are satisfied with the final product. This phase marked the successful completion of the project, with all objectives met and all documentation finalized.
Thank you, Abdullah. Next is planning of the project. First is project overview. The objective is to define the project scope, goals and deliverables. Timeline is a milestone and deadlines. Second is machinery requirement. Types of machinery: concrete mixer for producing precast component, cranes for lifting heavy panels and modules, forklift for transporting materials on site, scaffolding for safety and safe during assembly, quantity and specification, assess the quantity needed based on project size, determine specification based on material and design requirement, logistic, schedule deliveries of machinery, plan for on-site storage and maintenance. Next is labor requirement. Types of labor: skilled labor and general labor. Skilled labor is like engineer, architects and skilled tradespeople. Example, electrician and plumbers. General labor, helpers and unskilled workers for manual tasks, supervisory staff, project managers and site supervisors for oversight. Labor schedule. Labor schedule create a detailed work schedule align labor availability with machinery usage. Training to ensure all personnel trained in machinery operation and safety protocol. Next is work schedule for IBS project. As we can see, the work schedule for IBS project already separate in 3 different items. First is days, second hours, and third is breaks. Days, 6 days a week from Monday to Saturday. Hours, 8 hours days, 8 a.m. until 5 p.m. and Saturdays are half days, 8 a.m. until 1 p.m. For the breaks, 1 hour lunch and 2 50 minutes breaks daily, 1 50 minutes breaks on Saturdays. On August 2024, we start it with client intention from week 2 until week 3. On week 4 in August 2024, we does a feasibility study until week 1 October 2024. Next is design and costing. We does it on October 2024 in week 2 until December 2024 in week 2. Next is tendering. We does a tendering in December 2024 from week 3 until the next year February 2025 in week 1. Next, we continue with contract. We does a contract in February 2025 from week 2 until week 3. And finally, we does a construction starting from February 2025 in week 4 until the building is completely finished. For the next explanation about schedule for IBS project, I will pass it to my teammates.
As you can see, the construction process took 10 months starting for the 4th week of February 2025 to the 2nd week of October 2025. Furthermore, handling over and completion and handover only takes a month while utilization and maintenance takes 7 weeks. The next one is cost of IBS project. The cost of an industrial building system which project for a 2-story bungalow in Malaysia can range from 1.4 million to over 5 million, depending on various factors like location, design, materials and finishes. Key cost components include the first one, initial investment, which is equipment, setup and training. It is starting from 1,015,000 to 3,915,000. The second one is material costs. Material cost, it is breakers, canals and other materials, which is start from 155 million to 520 million. The third one is labor cost. Labor cost, specialized labor for IBS, totaling 100,000 to 300,000 based on project duration and team size. The fourth one is transportation and logistic cost. Transport and handling of IBS component estimated at 13,000 to 18,000. The last one is project management and supervision. Management fees and site safety compliance costs ranging from 16,000 to 115,000. Overall estimated total cost for this cost of IBS project is a 1,395 million to 5 million and above. These estimates depend on project specific, market conditions, and vendor pricing. Accurate budgeting requires quotes from suppliers and contracts.
Next, I will go into organized supervision and quality checking in IBS construction. First, establish quality standard to define the quality standard and prefabricated components, including materials, dimensions, and performance criteria. Second, choose qualified person or personnel that are trained and qualified to oversee quality control, including supervisors, inspectors, and site engineers. Third, establish clear communication protocols between the factory, project site, and supplier to ensure smooth coordination. Appoint a dedicated quality supervisor at the manufacturing facility to oversee the production for IBS component. Fifth, store IBS component in a manner that prevents damage and deterioration with proper handling to avoid deformation and defects. Lastly, assembly supervision to monitor the installation process, ensuring alignment, placement, leveling are correct, smooth, and no defect. Next, I will go into efficient management and resources during supervision and quality checking. First, set clear measurable quality standard supervision goal and ensure every personnel or person involved in the process understands the goals. Second, make frequent meetings to track progress and addresses any problem promptly. Third, implement automated tools for data collection, monitoring and reporting to reduce manual errors and speed up the process. Fourth, ensuring the team has enough personnel to handle tasks efficiently. Fifth, provide continuous training to staff to enhance their skill to reduce the needs for corrective action during quality checks. Number 6. Prioritize tasks based on urgency and importance to ensure that supervision and quality checks are integrated into the workflow without causing delay. 7. Establish clear protocols for identifying, addressing and resolving quality issues and promptly. Number 8. Foster a collaborative work culture where everyone contributes to maintaining quality standards. Next, I will go into ways to enhance site supervision. Number 1. The use of technology and digital tools, such as mobile application. Use construction management apps for real-time updates, tracking progress, and sharing information with teams. We can also use building information modeling. By utilizing building information modeling for better visualization of the project and to foresee issues before they arise on site. Second, clear communication channels. Conduct regular meetings with site teams to discuss daily targets, challenge and safety protocols. Ensure that supervisors are accessible for reporting issues and use walkie-talkies or mobile phone for instant communication. Third, regular inspection and audits. Schedule periodic check to ensure adherence to design quality standards and safety regulation. Perform quality control audits at different stages of the project to ensure work aligns with the specification.
My friend has explained 3 ways to enhance site supervision, so I will explain the rest. The fourth one is provide training for supervisor. There is 2 major points. The first one is ongoing training. Provide supervisors with regular training on construction techniques, technology updates and safety practices. The second point is workshop and seminar. Hold workshops on leadership, conflict management and technical skills to boost supervisors' effectiveness. The fifth point is focus on safety management. The first major point is safety training. Conduct frequent safety briefings and ensure supervisors are trained in emergency procedures and risk assessment. The last one is engage in effective resource management. The first point is monitor equipment usage. Keep track of the equipment, materials and manpower available on site to avoid shortage of delays. The last major point is adjust resources based on demand. Allocate resources dynamically, ensuring they are aligned with the project timeline and site conditions.
In conclusion, the IBS approach is a highly effective and innovative method that offers numerous advantages in terms of cost, time, and sustainability. By utilizing prefabricated components manufactured in a controlled environment, IBS significantly reduces material waste, minimize labor costs, and ensure consistent quality and precision throughout the project. One of the standout benefits of IBS is ability to shorten construction timelines. This is achieved through quick on-site assembly, making IBS project more efficient compared to traditional building method. Additionally, IBS support eco-friendly practice by reducing waste and energy usage while simultaneously improving the energy efficiency of the finished structure. With proper planning, skilled labor, and strict adherence to IBS guidelines, this method delivers a modern, durable, and cost-effective home. It is a construction solution that not only meet functional and aesthetic requirements but also align with the growing demand for sustainable building practice. That's all from our group. Thank you very much.